Today we are going to be learning about scatter plots. Once we know what a scatter plot is, then we'll also look at how to write a line of best fit. So to start, a scatter plot is just a graph that shows a relationship between two data sets. They're going to be graphed as ordered pairs in a coordinate plane. And then once you have those graphed, you can look for relationships between the two sets of data. So there are four different types of relationships that we're going to talk about in this video. They correspond with the types of slope that we've already worked on this year. So you have a positive linear relationship. That means if the x value increases, so does the y value. So maybe something like if the weather outside gets warmer, there might be more ice cream that's sold on a particular day. Okay, a negative linear relationship means if x gets bigger, y is going to get smaller. So if we're still sticking with temperature, maybe that could be something like as it gets warmer outside, there might be less hot chocolate sold. You have nonlinear relationships, so that would be if it's curved, it could be a different curve. You could also have something that goes a little bit more like that, but something where you can still see the trend of what's happening. Okay, and no relationship, you just kind of have dots all over the place and you can't really make any sort of connection between your two variables. All right, we're going to start with this scatter plot. We have the number of SUVs sold from 2009 to 2014. So we're just going to use that to make some predictions. The thing with scatter plots is you're using the trend to make a guess. It's probably not going to be exact. So for part A, we're going to look at when there were 1,000 SUVs sold. So we're going to follow this across and then follow it down, and we're going to see that that happens in 2011. Okay, we can go the opposite direction, starting with the year. We can follow this up if we're trying to figure out the number sold in 2013, and then we can go across. So it's a little bit less than where 900 would be. So I'm going to make a guess that maybe that's about 850 SUVs. And then describe the relationship. This is kind of forming a line. It's trending down. So that would be a negative linear relationship. Okay, hopefully all of that is going to be pretty familiar. You've looked at graphs before, looked at how to use one variable to get the other. Now it's just a little bit more of an estimate instead of an exact value. Okay, for this next one, we have a scatter plot where we have the number of minutes spent studying and the test score. So the type of relationship, this seems to be going up in a linear pattern. So for part A, I could say that this is a positive linear relationship. And then part B, it says interpret. So interpret means we're going to connect words with what we're describing. So I could say something like, as study time increases, test scores also tend to increase. All right, now that we kind of have the basics of a scatter plot, we're going to connect that with writing equations. So with a scatter plot, it's not going to form a perfect line typically. So what we'll use is something called a line of fit or a line of best fit. And that's where you're going to draw in a line that's as close to most of the data points as you can get it. And then that can be used to make an estimate, especially if you're estimating for numbers that are off of the graph. Okay, let's work through an example with that. So this time we're going to be looking at vacation and how far away you are from home over a given 6-hour period. So first we're just going to make a scatter plot and then we'll be able to find our line of best fit. We have an x value of hours and then our y value was distance in miles. Our scale for the x-axis looks like it only needs to go up to 6. So we'll space that out starting at 0. I'll just number every other one. And then on the y-axis, we need to go up to about at least maybe 350. So I'm going to count by 20s all the way up, and I think that should be enough. So 20, 40, 60, 80, 100, 120, 40, 60, 80, 200, have 300 there, and then 320, and then that should give me enough space. Okay, we'll do a plot or a point where each of these ordered pairs would be. So the first one is at 162. So right one up about 62. The board's a little bit off. That maybe should be a little lower. Then we're going to go over 2, up 123. So approximately right there. Again, my board's a little off, so touch lower than that. 3 hours would be about 188. So we'll go up about there. 4 hours would be 228. So we'll go up to 200, roughly there. 5 hours would be 280. And then 6 hours would be 344, so a little bit higher than that. Okay, so we have a scatter plot for part A, and now we're going to write an equation. So remember when we did slope-intercept form, we did y equals mx plus b. So m is going to represent the slope of the line, and b is going to represent your y-intercept. Okay, so we need to get our line of fit, and this just is kind of playing with it a little bit. I'm going to start with a line like this, and then I can adjust it as needed. This one's a good one to use a ruler for so that you can actually shift it before you draw in the line. So that looks pretty close. I'm able to hit about 3 or 4 of the points. Any extra points, you want to try to have half of the extra on top and half of the extra below the line, and that'll make sure that it's kind of in the middle. So this will vary a little bit. It might not be the exact same line that another student drew, but you want it to try to get as many points as possible with any leftovers half on top and half below that line. Okay, so we're going to do an estimate for our equation. I can draw in a slope triangle. I'm going to use 2 points that are on the line or a little bit closer. So I'm going to choose this one and this one. That would have been my 1 hour and my 6 hour. So I'm going to actually use the values that they gave me. That'll help a little bit than trying to work backwards and estimate. So my vertical distance went from 62 up to 344. So we'll just subtract to see what that distance was. So it looks like it went up 282, and then I went from 1 over to 6, so that would be a distance of 5. So when I do slope, I can write it as 282 over 5, or divided by 5. And I just plugged that into a calculator. It came out to 56.4. So this is all estimates. I could keep it with the tenths place if I really wanted to, but because it's an estimate, I'm just going to round to 56 for this one. So I've got a slope of 56, and then the y-intercept, if I had to guess what this point is right there, I'd say that that's probably somewhere around 10. It's about halfway between the 0 and the 20. So I'm going to use 10 for my y-intercept. And when I plug this in, I'm going to have y equals 56x plus 10. And that's going to be my answer to the second part where it asked for an equation. Okay, then I can use that to figure out number of miles per hour. That's my unit rate. That's going to be the same as the slope. So that's about 56 miles per hour. So about 56 miles per hour. I have part B written below. How far from home were you when you started? Since our y-intercept is at 10, that would mean that we were about 10 miles from home. And then the distance from home that you would be in 7 hours, we can use our equation here and substitute in 7 in place of x. So I could do y equals 56 times 7 plus 10. 56 times 7 is 392. And then when you add 10, you're going to get 402. So if we're really estimating, we could say maybe around 400 miles. Since I got 402, I'll go ahead and write 402 miles here. Okay, so again, keep in mind there's going to be some variation in the numbers that you get. It's going to depend on how you drew your line. It's going to depend on which 2 points that you chose. So typically I'll have a range of values that would be acceptable for your slope and a range of values that would be acceptable for your y-intercept. But then ultimately you can just use your equation to make some predictions. All right, that concludes our video notes for today on scatter plots and lines of best fit.